The electric vehicle revolution has been unstoppable up until now. China, the world's biggest car market and EV producer, might be about to change everything. Whispers are swirling about a new breakthrough so disruptive that even Tesla's own Elon Musk is reportedly paying close attention. It's good to see electric vehicles making progress in China. Some say it could make electric cars obsolete overnight. Others believe it could shake the entire auto industry to its core. But what exactly is this new technology? And could it really end the EV era before it even reaches its peak? Let's find out. In a stunning announcement that has sent shockwaves through the automotive world, China claims to be on the verge of unveiling an engine technology so revolutionary that it could render electric vehicles obsolete. This bold assertion comes with the endorsement of China's highest office, with the president himself suggesting this innovation has the potential to completely upend the EV industry's rapid global expansion. But is this truly the transportation breakthrough of the century, or simply another grandiose claim in the increasingly competitive global automotive market? Before discovering what this mysterious new engine actually is, and whether it lives up to its revolutionary promise, we need to examine the full context of how transportation technology reached this climactic moment. For more than a century, the internal combustion engine has ruled the world. From the earliest automobiles to modern-day supercars, ICE technology has been at the core of transportation, powering everything from family sedans to commercial trucks, airplanes, and ships. But while the ICE has long been seen as the pinnacle of automotive engineering, its reign is now facing an undeniable decline. With increasing environmental regulations, rising fuel costs, and growing interest in alternative power sources, the world is shifting away from gasoline and diesel engines. China, a nation that played a significant role in the mass production and modernization of ICE, is now looking beyond them, leading the world into a new era of engine technology. To understand the significance of internal combustion engines, we need to go back to the late 19th century. The first commercially viable automobiles, such as the Benz patent Motorwagen in 1885, were powered by small gasoline engines. These early machines revolutionized personal transportation, making travel faster and more accessible than ever before. By the early 20th century, car manufacturers like Ford, with its groundbreaking assembly line, made gasoline-powered vehicles affordable for the masses. As cars became more prevalent, so did gasoline and diesel engines. Throughout the 20th century, innovations in engine design, fuel efficiency, and mechanical reliability led to the mass adoption of vehicles. The world built vast infrastructures around these engines: gas stations, oil refineries, highways, and manufacturing plants. Gasoline and diesel engines powered entire industries, from agriculture to logistics, ensuring their dominance in global transportation. But while ICE offered power and convenience, they also came with drawbacks, ones that would eventually lead to their decline. These engines are incredibly effective at converting fuel into motion. However, their efficiency comes at a cost. Pollution. The burning of fossil fuels releases harmful emissions such as carbon dioxide, better known as CO2, nitrogen oxides, and particulate matter, all of which contribute to air pollution and climate change. Throughout the late 20th century, governments and environmental agencies began imposing stricter regulations to curb pollution. The introduction of catalytic converters in the 1970s helped reduce toxic emissions. But even with advancements like fuel injection and turbocharging, ICE still remained major contributors to global CO2 emissions. Some experts predict that, in the future, personal vehicles could become obsolete, replaced by autonomous fleets of shared cars, buses, and high-speed transit systems. Yet with all the advances in modern transportation, the perfect engine still doesn't exist. Electric vehicles have their limitations. Hydrogen is still impractical. Public transit can't replace personal transportation everywhere. The potential benefits of self-driving cars are massive. They could reduce traffic accidents, eliminate the need for parking in crowded cities, and create a future where car ownership isn't necessary. People would simply summon a driverless vehicle whenever needed. But despite the progress, the challenges remain daunting. AI-driven cars struggle with unpredictable real-world conditions. Sensors can fail in bad weather, and AI systems have difficulty reacting to unexpected events, like pedestrians suddenly crossing the street. Regulations are also a major hurdle. Governments are hesitant to approve fully autonomous cars without rigorous safety testing. And perhaps most importantly, the infrastructure needed to support self-driving vehicles, like smart traffic lights and real-time road monitoring, doesn't yet exist on a large scale. Even if self-driving cars eventually succeed, they don't solve the biggest issue, the energy source powering them. Right now, most autonomous vehicle projects rely on EVs, meaning they still face the same battery limitations, charging problems, and environmental concerns that plague the electric revolution. That's why some believe the real future of transportation lies elsewhere. If electric vehicles aren't the ultimate solution, could hydrogen fuel be the answer? Some automakers, including Toyota, Honda, and Hyundai, believe so. The president of China said, "Our new engine will destroy the entire EV industry. Mark my words." The room, filled with executives from China's state-backed automakers, fell silent. Elon, according to insiders, leaned forward, listening intently as she continued. "No more EVs. We found a better way." Elon, who has been at the forefront of the electric revolution, was said to be visibly unsettled. One executive at the meeting later revealed that the discussion quickly turned to the presentation of this engine, which, unlike traditional hybrid systems, reportedly runs on an advanced hydrogen-assisted combustion cycle, coupled with ultra-efficient thermal energy recovery and a self-charging solid-state battery system. It is neither a full gasoline engine nor a standard electric motor. It is something entirely new. Insiders present at the meeting suggest that the engine achieves efficiency levels never seen before. Test models, they claim, can travel over a staggering 1,000 miles on a single fueling, with emissions so low they rival fully electric vehicles on the road. The secret lies in a revolutionary thermal recovery system that converts excess heat into additional power, drastically reducing energy waste. Meanwhile, a next-generation solid-state battery integrated into the system provides consistent, long-term energy storage, eliminating the need for external charging stations. If the reports are accurate, this breakthrough would not only solve the biggest weaknesses of EVs, but would also challenge the entire global auto industry. Several industry insiders believe that Beijing has been preparing for this moment for years. While the rest of the world rushed to build battery gigafactories, China quietly invested in alternative propulsion research, funding projects aimed at overcoming the limitations of both gasoline and electric power. Now it appears those efforts have paid off. A source close to one of China's largest automakers suggested that the new engine could be unveiled within the next 2 years. If that happens, it could send shockwaves through the industry, forcing automakers worldwide to abandon their current strategies. Do you think this could mean the end of transportation as we know it? Let us know in the comments.